Prova, prova, prova. One, two, three, test, test, audio test. Audio test, audio test. Last test. Hello everyone, this is engineer Ruggero Poletto from CFD Fair Service. We can start the webinar where today we're going to talk about Cloud HPC and a brand new feature which allows you to get hardware resources at a very competitive price. We're going to see pros and cons of this particular feature. I see there are quite a few of you, so I welcome you all to this webinar. And so we can start step by step, having a look at, first of all, the feature of the webinar. So just give me a second. I'm just setting up my desktop and starting the presentation. I hope you can hear me fine. In case, just let me know. We have a chat available at any time, and through that you can interact with me in order to get information of and interact with the person who is talking. So let's start with the presentation. Sorry, I wasn't ready with the presentation already starting. So as I said, on the right hand side there is a chat. You can write comments, write questions, ask clarifications to me at any time, so feel free to make these comments, and I try to reply as I do my presentation. So I try not to stop speaking, and I try to reply to you to your question or request of clarifications. As a small company presentation, CFD Fair Service is an Italian startup founded in 2018. Our headquarters is near Verona, in the north part of Italy, and we are specialized in software development, in particular as far as engineering applications are concerned. So we got a huge training into CFD, so computational fluid dynamics, a big training in FEA, so finite element analysis, so structure analysis basically, applied to engineering, mechanical engineering, but also civil engineering, I must say. In these years, actually a couple of years ago, we released our own cloud HPC platform, which is the platform we're going to see together today. And obviously, this is the main feature we're going to talk today, but we are also act as a consulting and engineering design. So we do consulting activities, and we support manufacturing industry and also service companies into building their own products and speed up and improve their own facilities in general. Today, as I said before, we're going to talk about cloud HPC. What is actually an HPC? HPC stands for high performance computing. It means a cluster or a very, very big computer or server which can be used in order to run engineering simulations. We all know that CFD analysis, but also FEA analysis, are very often highly demanding in terms of hardware resources required in order to actually complete the simulations. Often a CFD analysis is composed by a mesh made up of millions of cells, and it can take few hours up to few days in order to complete the simulation. So often we need a computer which is specialized into handling this type of tasks. A very powerful computer that can handle that. Well, thanks to the cloud, thanks to the internet, it is now possible to use the computer for all the time requested and just rent the computing power for the time that you need to run, for the time requested for you to run the simulation. So this is a quite interesting feature for the people, for engineering, because they can take advantage of computing power, huge computing power, but also they reduce their investments. They don't need to buy it, they can rent it just for the amount of time required for the simulation to be completed. So the main benefits of an HPC, and in particular the cloud HPC, are obviously the speed up of the simulations. Our simulation can scale, and we can provide for every single analysis up to 224 logical CPUs. So that can be used in order to run the simulation. Thanks to this, it is possible for manufacturing industry to just focus on their product. They don't need to set up a important IT infrastructure and take care of the infrastructure, because that is demanded, let's say, included in the service, is demanded to us, and so we just do that. We are specialized into doing that. And then obviously another advantage is that there are no investments, no system set up at the beginning. Everything is already, let's say, completely configured in order to run, and you just pay for what you use. Okay, so you don't have to buy a server, you don't have to buy a computer, you just pay for the amount of hours that you spend on the computer, the amount of hours that you are using actually the service. So let's talk a little bit the software which are currently available on the platform. There are obviously a huge number of software, and they are continuously updated. So this, let's say, list we're going to see today is valid today, but it may be not tomorrow, as from time to time we keep adding new software, new installations on the platform, and we make them available to the users. We have Blender, we have Calculus and Codester. Blender is very common in video editing and rendering. It's let's say a platform quite popular, I must say. We have Calculus and Codester, which are two software with the goal to run mechanical simulation, so FEA analysis, finite element analysis, structural analysis of, in particular, of mechanical engineering, but also for civil ones, in particular for Codester. More software now, the CFD part, which is composed by CodeSaturn, FDS, Fire Dynamic Simulator, and OpenFOAM. They are all CFD software, so software that are commonly used for computational fluid dynamics. But they're different. In particular, FDS is very common in civil engineering, in fire safety engineering simulations. It's been developed by this institute in USA. While the other two software are usually, even if they are general purpose CFD software, they are most of the time they are used in the mechanical industry, and in particular OpenFOAM is kind of increasing also in the industry in order to verify the pedestrian comfort, the comfort, the thermal comfort of the people in a place. And in particular in this period of COVID, let's say this sort of task is becoming more and more common. Lastly, as post-processors, I didn't mention, but we also have SmokeView obviously as a post-processor in order to see the simulations, to see the results of the simulation. As you're going to see today, it is possible to run the simulation and at the same time to have a look at the results of the simulation at runtime while the simulation is still performing. We have a desktop connectivity to the machine, so that allows us to use ParaView or SmokeView in order to view the results. Obviously, we also have some commercial software, the most important of which is Vento CFD. It's a CFD software developed in Italy by a small Italian company, and it is specialized in wind simulation, in particular all over buildings, stadium, theaters, houses, local houses, okay. And that is quite popular in Italy for this type of applications. So now that we have had an idea of the main software installed on the platform, we can see the main features of the platform itself. The most important of which is the scalability. What do I mean by scalability? It is the possibility to reduce the computational time by using a higher number of hardware resources. So the overall idea is that if we have to run a CFD analysis, we want to decrease the time required for us to get the results by using more and more computing hardware resources in order to actually solve that particular case. Scalability can have two different, let's say, variations. One is the horizontal scalability, which allows us to run simultaneous scenarios at the same time. So we can, in the cloud HPC, we can run as many scenarios and so get the results of all these scenarios in the time we get one single result. Okay, so we don't need to create a queue of these results and wait for the queue for one process to finish in order to start a new one. We can run all the processes one after the other at the same time simultaneously and get all the results at the same time. We also have the possibility to get a vertical scalability, which means we want to run a case which is bigger and bigger and reduce the time required for that particular case in order to get the results. Usually a case gets bigger as we increase the mesh dimensions of the simulation we want to run. As we increase the number of cells required for the simulation to get results, the number of cells we compute. Depending on the software, there are two tactics of parallelization, OpenMPI or multi-core approach, and OpenMPI, multi-core approach. We have both these parallelization ways. It depends a lot on the software. We're going to use whether we can use both, one or the other. Okay, it's never guaranteed that we can, at any software, use both these methods. One small note regards the fact that each single simulation can run on our platform up to 224 virtual CPUs, so logical CPUs at the same time. We can run as many simulations simultaneously at the same time, but each of these simulations can be up to these 224 CPUs. So let's move on and let's have a look at the feature of instance type and the feature in particular I mentioned before. The new instance type pre, which stands for preemptible, which is rather different compared to reg, which is the regular instance. The point is, when we launch the simulation, we can select the CPU, the RAM, so now it will be allocated per each CPU, and then we have a button which allows us to choose between a regular or a non-regular or pre-instance type. Okay. These are different instances which are used in order to run the simulation. And let's have a look at the features of these choices. In both cases, the system generates a virtual scene inside of which your simulation is going to be performed. So your simulation will be performed in a virtual machine which is dedicated to your simulations only. And this is both for regular machines and for virtual machines. The type of processor we currently use is a second generation AMD EPIC processor, which is found very fast and very effective for the CFD simulations in particular. And in both cases, we use the same type of processor, so no difference as far as the processor is concerned. In both cases, we can run simulations from one virtual CPU up to 224 virtual CPU. And we can allocate from 1 GB of RAM to almost 1800 GB of RAM. So in both cases, the configuration of the system is not affected by the type of instance in which we want to run the simulation. So no concern about this part. This is a further difference between the 2 points. The machine reservation. For instance, the machine is completely reserved for your needs and remains allocated for all the time requested for your simulation to be completed. While in case of a preemptible instance type, your machines won't be reserved to you. Okay, so it will be allowed to you to run the simulation, obviously, but the simulation won't be continuous. At any time, the machine can be taken out, can be restarted, actually reboots, okay, and the simulation can be stopped and then restart again. So the machine is not guaranteed to be reserved 100% of the time for your simulation. While I move on, there are some small complaints about the audio. I try to fix it, reducing the audio consumption by the system, and so I see what I can do. Okay, 1 second only, and just give me a second. Let me see. All right. I hope now it's better. So, as we said before, the machine is not reserved for the whole amount of time for your needs, but at any time the machine, in case of preemptible simulation, can reboot. Okay, so it can the simulation can the machine can restart basically from scratch the simulation. There is also an issue with the compatibility with all the software installed on the platform. Due to these reboots, not all the software installed on the platform are correctly configured in order to handle preemptible machines. Regular machines can handle all the software, but preemptible machine can handle, at the moment, only FDS and OpenFOAM. Obviously, we keep you posted as we increase the number of software that can be handled by preemptible machines, but what will happen is not that the other software won't work, but these two software are correctly configured in order that in case the reservation of the machine drops, so in case the machine reboots, okay, they won't start from scratch, but they start from the latest saved results computed by these two software. Other software, for instance called Saturn, doesn't have this feature. So in case you are using code Saturn, every time there is a reboot of the preemptible machine, your simulation starts from zero. Obviously, there is an advantage by using preemptible machine, and the main advantage regards the price. There is a 50% discount compared to regular machine in the CPU hour cost, so in the cost of the machine. So this is the real reason why preemptible machine becomes very useful and very likely to be used, in particular for these two software types. But do I need to set some peculiar configuration in FDS or in OpenFOAM in order to positively use preemptible machine? The reply to this question is obviously yes. We need to be, let's say, to keep under control the frequency at which these two software are writing the results. This frequency is not, let's say, configured by the platform, but it needs to be configured by the user that actually set up the case. I'm entering into the specifications of these two software, so don't get frustrated if you don't understand anything, or if you just understand it partially. Probably you are specialist of FDS, so you can understand more that part, or specialist of OpenFOAM, so you can understand more the second part. In FDS, we need to add this dump command, inside of which we find this DT restart. Okay, thanks to this, we specify the frequency in seconds, the frequency, how many seconds of simulated time are computed before a new restart file is generated, is saved on the hard drive. So we keep this under control, and in case the system reboots, okay, the new simulation will restart from the last dump of restart file generated by the system. So for instance, if we have performed for 100 seconds and we have the T restarts of 300 seconds, in case the system reboots, the simulation restarts at 300 seconds, which is the moment in which we saved the last restart file. For OpenFOAM, we have a similar situation. Obviously, the way we need to use in order to specify this frequency of saving, of writing results file is rather different. We need to specify start from latest time, and then we also specify the write control time step and write interval 100. Okay, this 100 represents the number of seconds or iterations that the solver needs to compute before saving a new restart file. This 100 is actually the equivalent of the DT restart we saw before. What we have more in OpenFOAM is the Purge write, which allows us, in this case, to keep only the 5 most recent results files and cancel all the older results files saved on the hard disk. Obviously, we can put any number over here, and if we put 0, it means that we keep all the written results. Okay, so we never cancel actually the results produced by the solver. Another nice feature of the platform regards the connectivity. It is possible to get connected to the running simulation obviously at any time using a VNC connection, so remote desktop, and also using an SSH connection, so through the terminal. That depends on how much you are familiar with the terminal or how much you are familiar with the VNC connection, but it's pretty much easy to set up the account to work with both methodologies, and then it's up to you actually. Probably in case of SSH connection, it's easier to get an implementation regarding, let's say, automation of the workflow. In the VNC connection, it's easier if you want to run post-processing on the cloud, if you want to see the current results of the simulation, if you want to monitor what's actually happening in your analysis. So you have these two methodologies which can be used at any time. And also simultaneously, obviously, okay, if you use SSH connection, doesn't mean that we can't use a remote desktop and the other way around. So if you use remote desktop, it means that we can also use SSH connection. So more feature regards the API, which are available. There is a guide, and it's a pretty nice feature which allows automation of the workflow. There is a good Linux integration thanks to a particular script, Cloud HPC exec we call it, which allows you to run and to execute the simulations directly from the terminal. And also it is possible to get support from directly. There is a chat, as we're going to see later, in the web application, and thanks to that chat it is possible to run the simulation and to get support if you are having troubles running the simulation. So now let's have a look at the test cases we are running today. We have a simple case for FDS. It's one case taken from the FDS examples. It's the stairs. We have a fire exploding here at the bottom, and we have obviously smoke propagation all over the staircase. So we're going to see that. This case is already generated, so I had to generate the FDS file, and we see how we can upload the case on the cloud and how we can actually launch the simulation using preemptible or regular instances. The case we're going to test with OpenFOAM regards the motorbike, which is another case very popular in OpenFOAM. We have already executed the mesh with Snappy, and we're going to launch this case through the web application and see how we can actually launch the simulation using the preemptible meshing. So let's start. Let's enter the web application. So here it is. I just move the window. 1 second. So this is the web application. It actually consists of two main pages, I would say. There is the storage, which is the case, the page in which we have to upload the files of our simulation, so the FDS file or all the files that are required by OpenFOAM in order to run. And then there is this simulation page, which is the page in which we actually tell the system to launch a new analysis. As you can see, there is a record that keeps track of all the simulations that have been performed since the beginning of time. Okay, what's been done in the system in order to launch analysis in the past. So let's look at the case we've used with FDS. So already the FDS. So entering this FDS folder, we can actually see the FDS file. So it's just the usual FDS file. It doesn't matter if you use a particular software to produce this file. Once that file is being produced, we just need to upload that on the cloud. We press yes, right? And with the option, we just take file and place it over. Okay. So I just set the case test. When I set the case name over here on the top. Okay. So now the thing is ready. So let's see. In my search, I have no is staircase command, and inside the folder I can add yes, I downloaded. Okay. So now let's go back to the page and look how I can run this particular parenthesis. So I just press add, and it says launch this page. So in this page, we can select the number of virtual CPU. So in this particular page, I select a small machine with a super CPU. The RAM to be allocated. Keep in mind that this allocation is proportional to the number of virtual CPU. So it's not 4 GB in total. It's 4 GB per virtual CPU. And since we are using 2 virtual CPUs, the total RAM allocated is equals to 8 GB. And then there is this option, the option we saw before, regards the regular instance. When it is activated, we are actually using regular instances. When it is not activated, we are actually using preemptible instances. So when it is not activated, we are actually saving 50% in terms of CPU hour costs. When it is activated, we go full price, but we are guaranteed that no restarts will affect our simulation. So in this case, we keep it unactivated, and then we move on with the option selection. The first regards the folder. We just specify the folder in which we want to execute the case. And then we need to specify the FDS version. Our case is specific to version 6.7.5 of FDS, but just another news regards the fact that we recently introduced FDS 6.7.6, so we are up to date with the most recent version of the FDS. So once we have completed the setup of the simulation, we just press save. And there it is. So in our summary, in our table which summarized all the simulation that has been performed, we can actually see that a new simulation is actually running. That simulation is configured on a 2 virtual CPU machine, standard RAM. You see here regular is not activated, so we are actually using a preemptible instance. And then the other features which regard the simulation, so the folder and the scripts, so the software version that we're going to use. There is obviously a start date, and there is not yet an end date because the simulation, as you can see, it is still running. How can I control or monitor the analysis? Well, I can do that by pressing View. View is the eye next to the running analysis, and currently the system is still generating the virtual machine. As I said before, every simulation is performed inside a virtual machine, which is always dedicated. And this time the virtual machine won't be reserved to us for all the amount of time of the simulation. It means that there may be some restarts. We're not sure. There may be, or maybe not, depending on how many preemptible simulations are running at this time. Okay, so it's not, sometimes there might not be restarts at all for the running analysis. As you can see, without me doing anything, step by step, the system is actually moving on, and step by step, we're going to see that the FDS simulation will be actually running. While wait for that, let's move on and see what's going for the motorbike case, so the OpenFOAM, the open case. So let's open the motorbike case folder. I just entered that by double-clicking. As you can see over here, everything is already completely set up in order to execute the OpenFOAM analysis. I have, for instance, undercoded the mesh defined. Actually, it's not yet defined. We can run that in the cloud. I have also the possibility on the system to procure all the input for OpenFOAM. As you can see, we can also see, I go back and forward in order to also the FDS. I just refresh see now, access to the desktop, to the remote desktop, so in here, actually, I can double click on the smoke view, and actually, we can open smoke view and actually have a quick view of the analysis. This is, as I said, I am on machine, I am on the home machine in which the machine is running, and as you can see, I'm now loading the suit, which is actually calculated by FDS simulation, and we can already see what FDS has calculated so far. Okay, so proceed simulation is on, and I can run the post processing at run while the simulation is still running. So we are still actually on a machine in which the simulation. If you want to stop the simulation, what I need to do is just press the stop button, which is available here, the summary table. To be I use this button, I can confirm stop, so save the results and stop the simulation. And the simulation will come to a full stop of the simulation, and will save the results into the spreadsheet. So the results will be saved under the folder in which I will first and then run the OpenFOAM simulation. So I just want to open control just to show you how we configure in order to save the results. 1 second. As you can see, we have the start from latest time and the write control 100, which is the frequency which is used in order to save the results of the system. So in order to correctly upload the case on cloud, I just go back to the original OpenFOAM folder, right click on that, and create a compressed folder containing all the OpenFOAM case. So I compress it in, you can compress it in or in any other format. I go back to this one and I upload this file. So I now go with Dropper and I am uploading this file on my record. Right? Sorry, so as you see, I'm uploading this file. It's actually contains the file, and this upload this compressed folder on the cloud. This is a little bit file size compared to the FDS one, so it might take a couple of really a couple minutes. This is the new for all. We first want to on the CFD part. So in sessions, we can see what I run and see. So okay, so 2 seconds. Okay, the mesh is available. So just select a machine. This can select okay, because usually mesh you never know how much cells you end up with. Under folder, I select the zip file, and under script, I go and select snapping. Okay, it is possible to run both OpenFOAM, and by OpenFOAM I mean the solver like SimpleFOAM, PimpleFOAM, and so forth, or Snappy, which is actually the procedure required by the system to actually generate a mesh with Snappy. So press save, and it starts the operation required in order to produce a mesh Snappy. So obviously it's up to you, correctly configured, in particular the Snappy XML file. The procedure actually is able to generate a mesh with well, while we wait for this mesh to be completed, I waited some question and I move on a little bit with the presentation. Actually, there's just, let's say, a summary of what we have just said, okay? And we have a last overview of the main features of the web application. So let's move back to the presentation. 1 second, the PC is actually loading the presentation. There it is, so we have to actually run. We have more features beyond the solver. As we have already seen, it is possible to generate meshes with Snappy, but not only with Snappy, it's possible to use NetGen, GMSH, or other particular mesh which are implemented into the platform. It is also possible to run customized script. This is actually an advanced feature, so not available to everybody. Actually, not all the features we mentioned today are available to everybody. Usually, when you register to the platform, you can benefit of 300 CPU hours for free. And during this period of time, you get a limited account. When you move to, let's say, a full account, so let's say a business account, you get all the features we mentioned today. Okay, so you can run also customized script, you can access remote desktop and stuff like that. As we said about the price, everything is based on the consumption, so you can use the platform, and then at the end of the month, the overall use of the previous month the month is calculated. All the files in the storage are made available just for 60 days, and then they are automatically cancelled from the system with no possibility to retrieve them. Usually this time is long enough for you to check the results, to compare these results with new scenarios you're running, but is, let's say, not intended for data archive. Okay, for these data are cancelled, and I don't suggest to you to use this platform for archiving data. The pricings, as we said, depends obviously on the type of instances you are using, but also on the amount of RAM you are allocating per virtual CPU. The more RAM you are allocated, the higher is the price. For regular instance, the price spans from 8 eurocent per CPU hour to 12 eurocent per CPU hour, depending on the RAM, from 1 to 8 gigabytes of RAM allocated. And all these prices are divided by 2 when you use preemptible instance. So when you get these instances, which are very cheap, very competitive, but they suffer from time to time of restarts. Okay, so the price goes from 4 eurocent to 6 eurocent per virtual CPU hour. This is a very, in particular, very interesting to be used for the 2 software I mentioned before, so FDS and OpenFOAM. So that's now this bit, but back and see what's happening in the simulation. We have here,